Crystal symmetry. Again, what is a symmetry operation? A symmetry operation is one that leaves the crystal and its environment invariant. That means it is indistinguishable between the original motif and the operated motif. It is an operation performed on an object or pattern or motif which brings it to a position which is absolutely indistinguishable from the old position. Symmetry defines the order resulting from how atoms are arranged and oriented in a crystal. It involves the study of 2D and 3D order of crystals. In total, there are 13 symmetry operators. These actions which result in no change to the order of atoms in the crystal structure. By combining different operators will give us point groups. And in total, we have 32 point groups. These point groups are geometrically unique units. Don't worry, we will learn about point groups towards the end of our course. Basically, crystals have inherent symmetry. The definite ordered arrangement of the faces and edges of a crystal is known as crystal symmetry. It is a powerful tool to study the internal structure of the crystals because crystals possess different symmetries or symmetry of elements. Basically, we can classify symmetry based on the operators. For instance, based on whether it takes an object to its mirror form or not. Okay, so we have symmetries, we have type 1 and type 2. Type 1 will take object to same form, which is proper. So this includes translation and rotation. Then we have type 2, which includes mirror and inversion. But for type 2, it does not take the object to the same form. That means it is improper or in mirror image form. Then we can also classify symmetry based whether if it is play a role in the shape of a crystal or not. So whether it is macroscopic or microscopic. But in this course, we are just focusing on macroscopic, which involve rotation, mirror, and inversion, because these influence the external shape of the crystal. While microscopic, which involve screw axis and glide reflection, this does not influence the external shape of the crystal. Symmetries can also be classified based on if the operator acts at a point or move a point. Okay, so symmetry that does not move a point include rotation, mirror, and inversion. This is the single ones, but we also have compound operator such as rotor reflection and rotor inversion. Then we also have symmetries that move a point, which involve translation, screw axis, and glide reflection. Alright, let's look at rotation or turn. So rotation is basically the action of turning a figure around a point or a vertex. Let's look at this illustration. So you can see the triangle is rotating on a vertex or a point to a certain angle. So this is rotation. In 2D symmetry operators, we have rotation axis 1, 2, 3, 4, or 6. We don't have 5. 1, 2, 3, 4, or 6. There's no 5. Later we will learn why there's no 5 rotation. Alright, so, and as we know, one full rotation is equal to 360 degree. Alright, then if you have rotation axis of 2, that means you have to divide 360 divided by 2. And the same goes with 3, 4, or 6. You have to divide 360 divided by 3, 4, or 6 respectively to give you 120, 90, or 60. Okay, let's look at this figure. You can see it is rotating at certain angles on a vertex or the point. Here is the point. All right. So in rotation, it is really important to note that all of this angle or the rotation, okay, will give you different symbols. As we said just now, if it rotates, rotation axis is 2, that means it is twofold. If 3 is threefold, 4 fourfold, and 6 is sixfold. If rotation axis is at 1 or 360 degree, so we don't have any fold here, we just call it 360 rotation, and there's no symbol. But for twofold, 180, this is the symbol. It's like a hemisphere or ellipse. Okay, make sure you draw your symbols properly. Okay, for rotation, you have to shade the shape or color the shape. So you have threefold is a triangle, and then fourfold, sixfold. Okay, so you really need to know the by rules. Okay, because why? Later on, when we look at other symmetry operators, they also have different symbols. So make sure you can draw properly the correct symbol for the correct symmetry operators. Okay, so please practice to draw, and remember, twofold is like this, threefold is triangle, make sure you colored it. Okay, fourfold and sixfold. There's no symbol for onefold. Okay, so that's all for now. I'll see you in the next lecture.